Hello everyone. Today we are going to solve a problem from fortnight 21 of SuMON level 3 program. This is a hard problem from our worksheet. The problem goes like this. You are given with a triplet and you can consider any two numbers a comma b of the triplet and you can replace it with a minus b upon root 2 and a plus b upon root 2 for constructing the subsequent triplet. If this is the process by which you construct the triplets, then the question poses you with a starting sequence and also with the final sequence, and it asks you about determining the feasibility of reaching the final sequence from the initial sequence. So the trick and hint will be given in the video after clearly explaining the problem. Let's take one example for such a sequence. Suppose you start with 1, 2, 3. Then, as the next element of the triplet in the process, suppose if you take 1, 2, then that should be replaced with 2 minus 1 by root 2, 2 plus 1 by root 2, 3, because we do not disturb 3. So that should be isolated, and 2 minus 1 upon root 2 will be 1 by root 2. 2 plus 1 upon root 2 will be 3 by root 2, 3. Let's start with one of the sequences given in the question and check the feasibility for arriving at the final sequence. Let's get started. So here is the problem we are going to discuss today. The process is the same. If you start with a triplet, then you have to choose two numbers, erase them and replace them with their difference by root 2 and their sum by root 2. So here, consider it as absolute value of a minus b. So we start with the sequence 1, root 2, 1 plus root 2. And we wish to reach the triplet 2, root 2, 1 upon root 2 through the process mentioned before. Usually for these types of questions, there will be an invariant throughout the process. And if you are able to determine that invariant, possibly you can comment about the feasibility of reaching a sequence starting with some initial sequence. So determining the invariant might be a crucial step for these kind of problems. Though these two triplets do not share much in common, the process through which they go through can yield some notion about their property by which we can deduce their feasibility to reach the final triplet. So now, if it's possible and if the invariant is sort of logically coherent with the initial and final sequence, maybe you have to work further and determine some more properties of the underlying initial and final triplet. But for now, if you are really curious, pause the video here and determine the invariant by yourself. So let's try to figure out what is the invariant in this process. Consider the triplet ABC. After it goes through one step of the process, it changes to a minus b upon root 2, a plus b upon root 2, c by root 2. Just see. Let's just add the squares of all these three numbers. Before the process, it was clearly a square plus b square plus c square. Now after the process, it is a minus b upon root 2 the whole square plus a plus b upon root 2 the whole square plus c square. Now let's do some arithmetic here. Expand a minus b by root 2 whole square, which yields a square plus b square minus 2ab by 2 plus a square plus b square plus 2ab by 2 plus c square. Now clearly the minus 2ab and plus 2ab in the numerator cancels each other, and that yields a square plus b square plus c square, which is same as our earlier value for the preceding triplet. And this is just astonishing. And this invariant is going to help us solve the problem. First, notice that though the arithmetic is complicated, the sum of squares should not change. That's what we mean by invariant. Let's check this for our actual initial and final sequences. So our initial sequence is 1 root 2, 1 plus root 2. So when you square them individually and add, we get the following: 1 plus root 2 whole square, which is 1 plus 2 plus 1 plus 2 plus 2 root 2, which in turn is 3 plus 3, 6 plus 2 root 2. Alright, now let's go to the final sequence that we desire to attain. It will be 2 square plus root 2 the whole square plus 1 upon root 2 whole square, which will be 4 plus 2 plus 1 by 2. And this is 6 plus half, which is 6.5. Clearly, 6.5 is not equal to 6 plus 2 root 2. And indeed, it's less than 6 plus 2 root 2. So, this just implies that the final sequence can't be attained. It's infeasible. And that's why we are quite interested in the invariant to seek for proving infeasibility. Though it's possible that the question could ask you for proving a feasible final sequence, in which case you have to work further and derive some more properties on it. But for this case and most of the cases similar to this problem, the answer is no. You cannot obtain. And of course, if it's possible to obtain, you have to give the proper approach. And if it's not possible, you just need to give one contradiction through the process. And we have given that using the invariant, which is sum of squares. So this is how we solve problem at our SuMON program. All our problems are intriguing as per our students' feedback. So join us to solve more problems like this. Meet you in the next SuMON solution video. Thank you everyone. Bye.